Hey everybody, and welcome to our GWT lesson for Unit 3, Day 1, which is on classifying triangles by side length and angle measure. Now, when we are classifying a triangle, what that means is we're just saying what type it is. So classifying is basically saying, again, what type. And oftentimes, students come into this class knowing about most of the different types of triangles that exist. So this is going to be more of a refresher than it is anything else for most of us. So first and foremost here in the warm-up box, what is a triangle? That's pretty trivial, right? We know that it's going to be a shape with three sides. So in the box to the right here, number 2, it says draw a picture of triangle ABC. Now you can see that highlighted symbol right there. When we name a triangle, we name it by putting that triangle symbol out in front of 3 letters, and those 3 letters are the names of the corners. So we can see this triangle here in purple has corners of A, B, and C. The order does not matter. So if we called this angle CAB, CBA, BCA, does not matter. We put the triangle symbol, and then just the 3 corners are going to have those 3 letters. Now, a triangle has 3 sides. Those sides are obviously segments. So we can see like this side AB, this side BC, and this side right here is AC. So those are the 3 sides of the triangle. And then the vertices, which are also the corners, are A, B, and C. Here, here, and here. Okay. Now, I want to remind you that at any point, if you need to pause or rewind or anything like that, by all means, feel free to do so. And then just continue as you're ready. Now, example C and D here. C says, name the angle opposite segment AB. Opposite in this case means across from. So if we look at segment AB, we see that's this one right here that's highlighted. So when it says name the angle opposite of that, well, if AB is this side right here, you can see this arrow is drawn here and it's taking us right at angle C. Therefore, angle C is opposite of segment AB. Likewise, when it says name the side opposite of angle ABC, remember that the middle letter is the vertex. So we want to know what side is opposite of angle B, or what side is across from angle B. So if we were to start at angle B up here at the top, we follow this arrow through the triangle and we see that this side down here, AC, is across from it, or it's opposite of angle B. So these are some terms we're going to be using throughout this lesson and then throughout the course later on. Okay, so those are some basic vocabulary components of triangles. Now, when it comes to the types of triangles that exist, typically students have seen these 3 before. We have scalene triangles, we have isosceles triangles, and we have equilateral triangles. All 3 of those have to do with the side lengths of the triangle, right? How long are the 3 different sides? So scalene means that no sides are the same length. So maybe one side is 3, one side is 4, one side is 5. Okay, all 3 sides are different. So in this little doodle here, you can see that 1 tick mark, 2 tick marks, 3 tick marks. These are indicating that all 3 sides are different lengths. Okay. The second way we can classify a triangle based on its sides is to say that it is isosceles. Now, an isosceles triangle has 2 out of the 3 sides that are the same length. Okay, so this side here and this side here are the same, but that third side is different. Okay, so scalene, none are the same. Isosceles, 2 are the same. And then for an equilateral triangle, we kind of see this word equa, or that prefix equa, meaning equal. And then lateral means sides. Like if you're moving laterally, you're moving sideways. So equilateral directly translates to equal sides. All 3 sides of the triangle are the same length. So in an equilateral triangle, all 3 sides are the same. Okay? So these 3 terms tell us information about the side lengths of the triangle and how they relate. Okay, we don't know anything about the angles, but the sides are dependent on those names. Okay, so if we want to know about the angles, we have 4 more words here. these four all have to do with angle measures within the triangle. Nothing to do with the sides, just the angles. So an acute triangle is when all three angles are acute. In other words, all three are less than 90. An obtuse triangle is when one angle is obtuse. Okay, it's more than 90 degrees. A right triangle is when one of the angles is 90 degrees. It's a right angle. And then typically the one that students haven't heard of when they've come to this class is equiangular. Again, it's got that prefix of equa, meaning equal, and angular, meaning angles. So equiangular directly translates to equal angles. This is when all three angles are the same size. So we can see we've got those arcs. Okay, so what you'll see is examples that say something like this. Classify the triangles by side lengths. So my answers are going to come from here, my side length section. If all three sides are different, it's scalene. If two out of the three sides are the same, it's isosceles. If all three are the same, it's equilateral. So we can see here it says AC is 5, CB is 5, AB is 5. So all three sides are 5. All three sides are the same. This is equilateral. Okay, if we look here, DE is 11, DF is 6, EF is 14. All three of those sides are different from one another. That makes this scalene. None of the sides are the same. And lastly, LE is 23, LX is 23, here and here, and EX is 17. 2 out of the 3 sides are the same. This is an isosceles triangle. Okay. Now, if we want to classify by angle measures, the different ways we can do that, right? We want to talk about their angle measures. Well, we have acute angles. All three are acute. We have obtuse. One of them is obtuse. We have right. One of the angles is a right angle or 90 degrees. Equiangular. All three angles are the same. So when we look at this first example here, we see 60, 50, 70. 60 is acute, 50 is acute, 70 is acute. All three angles are acute. Therefore, triangle ABC is an acute triangle. Whereas if we look at the next one, angle D, 30 degrees, that's acute. But right here, angle E is 100, which is more than 90. Angle E is an obtuse angle, so automatically this is an obtuse triangle. Likewise, with triangle LEX, 44 is acute, but 90 degrees is a right angle. This triangle has a 90-degree angle in it. This is a right triangle. Lastly, 60, 60, 60. All of those are acute. So we might jump the gun here and we might say this is an acute triangle, but we can be more specific with our answer. And we can see that all three are the same. This is equiangular. Equal angles, all of them are the same. Okay. Now, the next example just blends these two concepts together, right? Everything we see in blue here is talking about the angle measurements, and everything in red is talking about the side lengths. So what we're going to do now is we're going to look at a triangle and give it two names, one based on angles, one based on sides. Okay? So classify this triangle based on its side lengths and its angle measurements. Well, I see 90, 45, 45. This 90 right here tells me that this is going to be a right triangle. 11, 18, 11. So two sides are the same. Two sides are the same, and I have a 90-degree angle. If two sides are the same, that means it's isosceles based on its sides. And if one of the angles is 90 degrees, that means it's a right angle. So this is called a right isosceles triangle. Okay, we use the angle name first, side second. So this is a right isosceles. As we continue to look at more examples here, okay, we see that we've got three sides that are the same and three angles that are the same. Therefore, when everything is the same, it's equiangular, equilateral. We look over here, we had a 90-degree angle, and these two sides were the same. So because we have a 90-degree angle, this is a right triangle, and it's isosceles because two sides are the same. Lastly, when we look at here, we see we have a 100-degree angle, which makes this obtuse. And then when I look at the three sides, none of them are the same. That's the definition of a scalene triangle. So this last example here is an obtuse scalene triangle. Okay. Now, something you might be asked to do is this. Instead of, here's a picture, tell me what it is, you might be given the opposite idea, which is draw the picture based on knowing what type of triangle it is. So example 1 here is acute scalene triangle RAM. And all it tells us to do is draw a picture of each of the following triangles. Fill in the side lengths and measures to explain. So you can really pick up or put down any numbers that you want as long as it matches that criteria. So acute means all three angles need to be less than 90. 60, 50, 70. Done. Scalene means that all three sides have to be different. None of them are the same. So that could be something like 1 tick mark, 2 tick marks, 3 tick marks. Or if you wanted to incorporate numbers, you could have said like 5, 6, 7. Just coming up with 3 random numbers that are all different from one another. Okay? Likewise, in example 2, an obtuse isosceles triangle SOX with obtuse angle X. So all I have to do is make sure that at angle X, I've got an angle measurement that's more than 90 degrees. I just came up with 110. You could put 105, you could put 100, you could put 91. Okay, as long as it's bigger than 90. And then it says it's isosceles, which means two sides have to be the same. So that's what this tick mark and this tick mark here indicate. Those two are the same. If you wanted to give numbers, you could do something like 10, 10, 12, or something like that to say, hey, these two sides are the same. This one is different. And then lastly over here, we have ourselves a right scalene triangle, CUB, with the right angle at C. So sure enough, right here at C, we've got our 90-degree angle. And then because it says scalene, none of the sides can be the same. 1 tick mark, 2 tick marks, 3 tick marks. Again, you can say 3, 4, 5 if you want to. Okay, you could put numbers, you could put tick marks, as long as you're clearly showing that these 3 sides are not the same. None of them are the same as one another. Okay, now our last example, I'm leaving example 1 here blank. If you want to come back to it and practice it on your own, I think that would be a great idea. But if we keep going one more time here, when we are classifying a triangle based on its sides and you're given vertices on the coordinate plane, what we have to do is we have to find out how long each side is. So the first one that's easiest to find out is this side right here. From A to B. We see that that's a length of 3 because we could just count side to side. That's what this red highlighted box here says. It says that if sides are perfectly flat, like this case AC, or straight up and down, we could just count boxes to figure out length. However, if they're not perfectly flat or not perfectly straight up and down, now we go back to using our distance formula, which we learned last unit. So if sides are slanted, we use the distance formula, and that's written there as a reminder. D equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So after finding out here that AC was 3, we have to figure out how long the other two sides are. So in green here, that's this side right here, AB. We can see that, again, using our distance formula, this is x1, y1. This is going to be x2, y2. And so when I plug those numbers into our formula here, we end up finding out that this side AB is 5.65, roughly. Okay. So now what I know is it can't be equilateral it can't be equilateral because this side is 3, this side is 5.65. Equilateral means all three sides are the same, and we already have two that aren't. So we can eliminate equilateral. It's either going to be isosceles if the last side is equal to one of the previous two that we've found, or it's going to be scalene if it's different than the two we've already found. So now we use the distance formula again using these points where this is now my x1, y1, and this is my x2, y2. We plug those numbers into the distance formula right here. We get that this blue side is 4.12, which is completely different than the 5.65 we found and the 3 we found, which is fine. All three sides are different. It's not isosceles. This is a scalene triangle. Okay. If you missed some of this, again, you've got the ability to rewind. You have the ability to pause if you kind of need to process or write some more stuff down. But I invite any questions that you may have. You can email me or just wait until class tomorrow, and I'll be happy to address those for you. But that is our lesson on classifying triangles. Thanks, everybody, and have a great rest of your day.